Solving two-step equations. To solve two-step equations, we still use inverse operations, similar to when we were solving just one-step equations. A reminder, the inverse operations, the inverse of addition is subtraction, and remember these work both ways, so the inverse of subtraction is addition, and the inverse of multiplication is division. Again, this works both ways, so the inverse or opposite of division would be multiplication. Now we're going to have to use two steps instead of just one step to isolate the variable. So to isolate the variable, we're going to have to undo two operations. The order in which we undo these operations, we are going to reverse the order of operations to solve an equation, which means we're generally speaking in most cases. Now there are some times that this is not true, but most times we're going to get rid of addition or subtraction first, and then we're going to get rid of multiplication and division. So the first example says 2x plus 11 equals 51. Our goal is still to isolate the variable, or in this case, get x by itself. The first thing we need to get rid of is what we're adding or subtracting to x. So in this example, we're adding 11 to 2x. So I need to get rid of adding 11 by subtracting 11 from both sides. 11 minus 11 cancels out on the left side of my equation, and on the right side, 51 minus 11 is 40. So I'm left with 2x equals 40. Again, I have not isolated my variable yet. This time I'm multiplying 2 times x equals 40. The opposite of multiplying x by 2 is to divide x by 2. And whatever I do to one side, I need to do to the other. So in this case, my answer is going to be x equals 20. Just like when we were solving one-step equations, you're going to want to go back and check your answer. So I'm just going to do this mentally, and I'll talk you guys through it as I'm doing this. So I need to substitute 20 in for x, which would give me 2 times 20, which is 40, plus 11 equals 51. Well, 40 plus 11 is 51, so 20 is the answer for x in this equation. The next example is 10 plus 2x equals negative 20. This one has been switched around just a little bit. Now I'm going to have the whole number 10 plus 2x, my variable. I still need to get rid of what's being added or subtracted to x first. What's being added is a positive 10. So I need to do the opposite of adding a positive 10, which is subtracting 10 from both sides. When I subtract 10, 10 minus 10 goes away on the left side. And negative 20 minus 10, do not forget to use your integer rules. We have same signs, so we're going to add the numbers and keep the sign. So my equation is now 2x equals negative 30. Now I'm multiplying x by 2. The inverse of multiplying by 2 is to divide both sides by 2. And I get x equals negative 15. Again, I need to go back and check my answer, which would be 10 plus 2 times negative 15 equals negative 20. Well, 2 times negative 15 is going to give you negative 30, which would give me 10 plus negative 30 equals negative 20, and that is true. The next example, we have 5 equals 3x minus 7. Notice in this case, my variable is on the right side of my equation. That's okay. I'm still going to use inverse operations, and I still need to do the same thing to both sides of the equation. So the first thing I look for is addition or subtraction to the variable. And if you look on the side with a variable, I'm subtracting 7. The opposite of subtracting 7 is to add 7 to both sides, which gives me 5 plus 7 is 12 equals 3x. Again, now I'm going to look for either multiplication or division. In this case, I'm multiplying x by 3. The opposite or inverse of multiplying by 3 is to divide both sides by 3, and that gives me 4 equals x. Going back and checking my answer, that would be 5 equals 3 times 4 minus 7. Well, 3 times 4 is 12, and 12 minus 7 does equal 5. So 4 is a solution for this equation. The next example, we have x divided by 5 plus 4 equals 10. Get rid of addition or subtraction first. The opposite of adding 4 is subtracting 4, so I need to subtract 4 from both sides. That would leave me with x divided by 5 equals 6. The opposite of dividing x by 5 is to multiply by 5, and I need to do that on both sides of the equation. On the left side, my 5's are going to cancel out and leave me with just 1x equals 6 times 5 is 30. Again, go back and I'm just going to mentally check my answer, plug it in, and we get 30 divided by 5 is 6. 6 plus 4 equals 10 is a true statement, so 30 is a solution to this equation. The last example, we have 6 plus x divided by 7 equals 9. What's being added or subtracted to my variable x is the 6 in the front, and it is positive. The opposite of adding a positive 6 is subtracting 6 from both sides because I need to keep my equation equal on both sides. That's going to leave me with x divided by 7 equals 3 because 9 minus 6 is 3. Now I need to get rid of dividing by 7 by multiplying by 7 on both sides. When I do that, my 7's cancel out on the left, leaving me with just 1x equals 7 times 3 is 21. Again, quickly I can check my answer. I have 6 plus 21 divided by 7 equals 9. Well, 21 divided by 7 is 3, so 6 plus 3 equals 9 is a true statement. 21 is the solution to this equation.